Okay, this problem can get a little tricky. We have three different slots to put CDs in, and I'm going to call them slot 1, slot 2, and slot 3. Now, for the first one, I have 10 choices. But once I use one of these CDs, I only have 9 choices for the second slot, and I only have 8 choices for the third slot, now that I've used 2 of them. But this kind of understanding, and want to know how many different ways I can do this, I come up with 720. This understanding is based on you caring about what order these CDs in. So let's say I chose CD A, CD B, and CD C. I would have this as one of my CD permutations, it's called actually. But let's say the next time I chose, B ended up in the first slot, A came up second, and C came up third again. These are actually the same 3 CDs. They're just in a different order. And I'm not sure this problem cares. In fact, I can see by the answers offered, it doesn't care. So we have to take out of this 720 the number of times the same 3Ds are chosen. They're just put into different orders, and that's called a combination. And let me write this down. If we had n things to choose from and we wanted to make a combination and we used k number of them, our formula would look like this. And it begins to use some nomenclature, which is easy to use, but if you're not familiar with it, it looks confusing. This factorial thing means to take a number. Let's say I had 5 factorial. That's what this exclamation point is called in probability. 5 factorial is 5 times 4 times 3 times 2 times 1. So to use this formula, we take n things, in this case 10 things, and we want to make a combination which uses 3 of them. And combinations, this formula is used when you don't care about order. So let's write down what we have. Our n is 10, so that goes on top. 10 factorial. Our k is how many of them I'm going to choose, and n minus k, in this case 10 minus 3 is 7. So let's actually expand all this. This 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is going to be 3 times 2 times 1 times 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. And you can see that what we're going to end up doing is having this fraction with all these factors on top and factors on bottom. Well, we know we can cancel out common factors on the top and bottom of a fraction. 3, 2, 1, 3, 2, 1, 4 cancels 4, 5 with 5, 6 with 6, 7 with 7. We also know that we can take out a factor of 3 on the bottom, and we can take out that same factor of 3 from 9. And what we're left with when we take 3 out of 9 is we're left with 3. 3 times 3 is 9. If I divide 8 by 2, I get 4. So now all we're left with on top is this combination of 10 things taken 3 ways. It simply turns out to be 10 times 3 times 4 all over 1, which is 120. Now some calculators will do 10 factorial. They'll have a factorial button. I don't know about the one in this case. Let me see what I've got on the one that comes with Word here. If we have a factorial. This is the scientific calculator. No, we do have a factorial button. So if I wanted to, I could have taken and found what 10 factorial was. 10 and hit the factorial button, I would have gotten 3,628,800. That's what happens when you multiply 10 times 9 times 8 times 7. So if I wanted to, I could have taken that number, 36288, 3628800, put it on top, and then called up my calculator again. It's down here. And we could have done 3 factorial on the bottom, which is 3 times 2 times 1, which is going to be 6, and times 7 factorial. 7 factorial times 6 would have gotten me 3240. 3240. And then if I would have divided those out, clear 3, 6, 2, 8, 8, 0, 0 divided by 3, 0, 2, 4, 0 equals 120. So I could have actually used a calculator, and I also would have gotten 120. I don't know any other way for you to understand combinations. Except for one, realize that you're working with a combination when the order of the things that they appear in when you pick them doesn't matter. And when you are working with combinations, this is the formula you have to use. I know on the PSSAs in 8th grade, on the PSSA formula sheet, I believe is the formula for combinations and permutations. You just have to know when to use them properly. I hope this has helped. At least you know the word combination now, and you can also Google that, look it up, and see if you can find more videos on how to calculate combinations when doing probability.